Welcome to the second part of sign law. So this is still 6.4, but we're looking specifically at ambiguous case. So going back to 6.3, when you were starting to create your own triangles, we saw some scenarios. One scenario was that we couldn't make any triangles, depending on the length of the second side. We saw a scenario where we could make one triangle, we could make two triangles, or because the side was too long, we might only be able to make one triangle again. That was that last example. You might have said that there was no triangles for that instance, but technically we could extend that line off the page and we would have had a scenario that looked something like this. Okay, so 0, 1, or 2 triangles were our options depending on the different lengths of the different sides. So this is what ambiguous case is all about. It's the idea that under some circumstances, you might end up with 2 triangles that you need to describe. So ambiguous case for sign law may occur when you are given 2 side lengths and the measure of an angle opposite one of these sides. Okay, so if the side across from the angle is smaller than your other side, you have ambiguous case. So this sounds very bizarre. This triangle gives you a picture. If we called this side M and this side N, we would have ambiguous case if M is smaller than N. Okay, if it's bigger than N, that was that last scenario I was describing where it only has one triangle because it's too long to give us a second one. So we've got 2 possible scenarios in terms of our angles. So this just talks about our sides, but what about if that angle that we're given is obtuse or acute? That changes things a little bit. So for our first of 4 possibilities with an acute angle, if A is acute and H is the height of the triangle, we can talk about these 4 possibilities. So option 1, so that side opposite our angle, so remember that we are talking about angle A is acute. If our opposite side is shorter than our other side, and it's shorter than our height, we will have no triangles formed. So we have no triangles if A is smaller than B and A is also smaller than our height. So remember, in this case, H is the height, not the hypotenuse. Okay. Okay. So our second option is that we get exactly one triangle, and that happened when our height was exactly the same length as our opposite side. So again, working with angle A, so side A is our opposite. And I'm just going to put it in quotes because we're not talking about necessarily a right angle triangle. For this particular case, it is a right triangle, and that's because the height is always going to form 90 degrees. It's always the shortest distance. It's going to be perpendicular. So in this case, one triangle if A is smaller than B and A is equal to the height. So how can we calculate the height? Well, we can use trig because the height is always going to form a right angle. Okay, because we take the shortest distance. So we would find the height disregarding A, because A is what we're going to be comparing to. So we're just looking at B and our angle. We would take sine of A equals H over B. B, we would have a value. So we can solve for height by doing our other side multiplied by sine of our angle. Okay, so that is one way of setting this up to check for your height. And then we can start comparing. Is A smaller than my height? If that's the case, no triangles are formed. If A is equal to the height, I'm going to have exactly one triangle. The second that A is one tiny measurement bigger than the height, we run into scenario number 4. Okay, so we get 2 triangles if A is smaller than B. So that still needs to be the case, okay? And that's going back to our definition of our ambiguous case. This must be a scenario in order to give us ambiguous case and when we're going to have to check for our height. But in this case, A will be bigger than height. And so what ends up happening is that's when our compass swings like this and touches this line in 2 separate spots. All of a sudden, we have 2 possible triangles. We've got triangle 1, which is the kind of default one, the one that's on the outside, giving us that obtuse angle at the top. Or we could end up with triangle number 2, which is this guy here, A, B, A. We get our obtuse angle actually in this corner. Okay, the height then actually has nothing to do with it. These 2 A's do not simultaneously exist. We do not have a third triangle that looks like this with A and A. Why isn't this the case? Well, this isn't the case because we need to still include angle A and side B. So this isosceles triangle is not actually a thing. It's just we see that extra triangle because these 2 sides form this invisible triangle. Our third case, but this is not part of ambiguous case, because it doesn't fit that descriptor of A is less than B. If we have one triangle if side B is less than side A. Or if you want to write it in the same order that we've been writing it so far, A is greater than B. Okay, so 1, 2, and 4 are ambiguous. You need to check to see which case you're dealing with. If you end up with scenario number 4, then you're going to be dealing with 2 triangles, okay? But if we deal with scenario 3, that's not even ambiguous. We don't need to worry about the height at all because we are only going to have one option. Because if we have that compass happening again, it's going to swing like this. And we would get another triangle forming over here, but technically that's not including angle A, so that doesn't work. That doesn't count as a second triangle. So that's ambiguous case for acute angles. But what about if angle A is obtuse? Oops, don't cross that out, highlight it. Okay, so H is height again. In this case, our height actually shows up here, which means that it's actually going to have no impact. We're going to have 2 scenarios. Well, it's going to have a minimal impact. You're going to have 2 scenarios. Either option 1, is that A is not long enough, and so we don't get a triangle. Or A is long enough, and we do get a triangle. But we still only get one triangle because we have to include this obtuse angle. And if one angle is obtuse in a triangle, our other two have to be acute. Okay, so there's no other option here. One of these can't be obtuse as well because this one already has taken up over 90 degrees of our 180 that are available in a triangle. So how do we check for this? Well, if A is smaller than B, we definitely don't have a triangle here. So the second that A is bigger than B, we will have a triangle and you're good to go. So there's no true ambiguous case here. It's just either yes or no. Do we or do we not have a triangle? So looking at this example, now I know it's called example 3. The reason that is because we're kind of continuing our sign law lesson from before. So we see triangle DEF, where side DE, so aka side F, is 5 centimeters long. Angle D is 80 degrees, and side FE, also known as side D, is 8 centimeters. Solve the triangle, give angle measurements to the nearest degree and side lengths to the nearest tenth of a centimeter. Now this is going to be consistent across the board in terms of nearest degree, tenth of a centimeter, or tenth of whatever measurement. So I always like to start by drawing a picture. My angles are never perfect. This is not 80 degrees, but it just gives me that visual representation to try and kind of wrap my head around it. So I've got 80 degrees, and that's angle D. So side D is going to be over here, and that's going to be 8 centimeters. We can call this EF. So DE, aka side F, is going to be 5 centimeters. Well, what kind of scenario are we dealing with? Well, part 1 is that we are dealing with an acute angle. Therefore, we need to check if I'm dealing with ambiguous case. So our opposite side, or side D, is longer than our fixed side. And so what we're going to say is D is larger than F. Is this an ambiguous case? If we go back to the previous page, if our kind of opposite side is larger than our fixed side, we're looking at piece number 3 here, scenario number 3, that is not ambiguous. I'm only going to have one triangle. This makes my life a lot easier because now I can just actually draw this in. Now 8 centimeters is much longer than 5, so I would stretch it out over here actually. And from here, I'm just going to use my sine law like I normally would. So I know that this set angle is 80 degrees. I need to solve for these two angles and this one missing side. So E, F, and side E. So I'm going to choose to solve for F first because I do have its opposite side, and I have my fixed ratio for D. I'm going to go angle on top because that's what I'm solving for. I'm solving for angle F. Plug and chug. So once you plug and chug, you get 38 degrees for F. Once I know two angles inside my triangle, I can solve for the third. So I know this is 38 degrees. So I can solve for angle E by going 180 minus D and F. I go 180 minus 80 plus 38, and I get 62 degrees. And so now I've solved for both my angles. Now I need to solve for my missing side. I'm going to use my same D ratio. I'm going to, oops. Okay, I'm going to use that D ratio again because it's those fixed values that I didn't have to solve for. So again, the less I use values that I've had to calculate, the better off I'm going to be in the long run, because I'm not going to have numbers maybe that I messed up here carrying through and affecting all my other answers. So I've got these two so far, but I'm going to leave those out as much as possible. Now I'm going to have to use angle E, but I'm not going to use side F just in case something else is wrong, because I could start getting some pretty funky answers if I've messed up this angle, which then messed up this angle, and so forth. So to solve for side E, I'm going to put E in the numerator, sine of the angle in the denominator, and this is what I'm going to use. I'm going to plug and chug to get my answer. So again, you plug and chug, you want to move your sine 62 over so that you're isolating your variable, and then you can plug this in. If you have a funky calculator where you're not 100% sure how to plug in each trig function, calculate each of those, write down their decimal values, then punch that in separately. Okay, especially if you don't have a two-line calculator, I definitely recommend you do each piece individually to avoid any like calculation errors. Okay, and we get 7.17. It says keep to the nearest tenth, so I'm going to round it to 7.2 and keep my units centimeters, and that's for side E. So I'm done this question. Woohoo! Okay, so I know it was a number of calculations. We had 3 different calculations we needed to do, but we're still just applying sine law in this case. In the next example, we have a triangle ABC where A is 24 centimeters, angle A is 30 degrees, and B is 42 centimeters. Solve the triangle or triangles, give the angle measures in the nearest degree, and the lengths to the nearest tenth of a centimeter. So I start by again just sketching a picture for myself. Angle A is going to be 30 degrees. Side A is 24, and side B is 42. Okay, in this case, I can see that my opposite side, side A, is smaller than side B. Going back to our discussion of what makes ambiguous case, if I have an acute angle, which I do here, okay, because it's less than 90 degrees, and A is less than B, that means that it is ambiguous. So now I need to check my height. So again, I disregard this piece to check my height, because my height I know is the straight up and down line that's going to form here, that vertical height, and it forms a right angle. So I can check for height by again setting up my opposite over hypotenuse. So I'm going to use sine of 30 degrees equals h over 42. So h is going to be 21 centimeters. Okay, and again, multiply by 42 on both sides to get it out of the denominator. So if I get this value, well, how does A compare to H? Well, A is bigger than H. Which one of those 3 ambiguous case scenarios are we dealing with? Scroll back. We are dealing with scenario number 4. A is bigger than H, and so we are going to have 2 triangles. So in general, what are my triangles going to look like? You've got lots of space here because this is going to be a pretty chunky question. So I'm just going to enlarge this picture now that I've kind of wrapped my head around it. So I've got 42 centimeters here. I've got a 30-degree angle here. That's a little bit more accurate than my 80 in the previous question. I have two options. Either my 24 is going to be here, or it could be here. So I've got two triangles. Hypothetically, these should be the same length. And so I'm going to actually deal with two separate triangles when I'm doing my calculations. So triangle number one, always use the one that's our wider triangle to start with. So again, I just kind of sketch it out on its own. 42 centimeters by 24 centimeters, 30 degrees. This is the one that is automatically going to be kind of solved for when we use sine law. So we can solve for this base angle next. Okay, so we had A, C, B. So we're going to solve for angle B. And so when we do that, we've got sine B over B equals sine A over A, and we're going to plug and check. So angle B for triangle 1 is 61 degrees. I can then solve for angle C by going 180 minus A and B, A plus B. So it's going to be 180 minus 91 is going to be 89 degrees. So that's angle C. And I'm putting these little subscript ones to signify that they are part of the first triangle that I'm considering. Now the last thing I need to find is my side C. Again, I'm going to just use my sine law, and I'm going to use my C's, and again the A's because they were given. I've got side C over sine C equals side A over sine A, and plug and chug. And again, I get 47.99. I round to the nearest tenth, so I'm going to go 48.0 centimeters. Always include units, degrees for your angles, and measurements here. So that's C1. So that's all triangle 1. That's beautiful. What about triangle 2? How am I going to figure that out if everything kind of defaults to solving for triangle 1? Well, the key thing to note is, again, that this is an isosceles triangle, this imaginary triangle that doesn't have to do with our final triangle that we're solving for. It's an isosceles, and if sides are equal, our base angles also end up being equal. So we know that B1 was 61 degrees. So this angle here is also 61 degrees. Now that's still not part of our triangle that we're actually looking at. This is triangle 2 right here. Okay, but we can solve for the interior obtuse angle because this whole piece is a straight line, and straight lines add up to 180 degrees. So when we look at triangle 2, we can calculate angle B by taking 180 minus B1. In this case, we're subtracting 61, which gives me 119 degrees. So that's B2. Now that I know that, and I know my triangle looks like this, 30 degrees, 119 degrees, 42 centimeters, 24 centimeters. All I need to do, all that's left, is to solve for angle C and side C. Well, again, angle C is going to be 180 minus these other two. It's 119 plus 30. And so that lets me check. I get 31 degrees. So this is going to be super, super close in terms of measurements. These two angles are going to be very similar. So I already know that side C is probably going to be pretty darn close to 24 using that same rule of isosceles triangles. This is not always going to be the case. It just works out very nicely in this particular example. So I need to solve for side C because I now know angle C is 31 degrees. So again, opposites, I'm going to use my givens. So I'm still going to use that ratio for A. So side C over sine angle C equals A over sine of angle A. Plug and check. As predicted, it's pretty close to 24. To the nearest tenth, it's going to be 24.7 centimeters, and that is C2. So those are all my answers. Okay, so triangle 2 has its set of values, triangle 1 has its set of values. An ambiguous case that ends up with two triangles is not complete until you have solved both scenarios. So looking over this in general, we've got ambiguous case occurs when our opposite side is smaller than our fixed side when we're given two sides and an angle. And we are only able to determine what of our three cases it is within that ambiguous umbrella if we determine the height of our triangle. So those are kind of those big ideas that we're going to be looking for. You've got practice questions in your workbook to do. If you need extra practice for ambiguous case, please let me know and I'd be more than happy to give it to you, because that is probably some of the hardest concepts to understand of this unit, is the whole idea of ambiguous case. So good luck, and then when you're ready, we can move on to the last lesson of the unit, which is cosine law.